Morning, year 13. So here is your online lesson about the double angle formulae. Feel free to ask any questions as we go through it. I'm sure you won't. So put stuff in the chat if you're more comfortable doing that. If I'm going too fast, if there's something you want me to go through again, you just have to ask like we was in class, okay? As usual, I'm going to go through my notes, go through a couple of examples, then ask you to do a couple, and there'll be some awkward silence, and then I'll go through the answers to the ones I've asked you to do, right? So, if you remember, last time we had some sort of lesson, I can't even remember when that was, I introduced you to a topic called R alpha, and it was all about these identities here, these top two identities that you can see that are in the formula booklet for sine and cos and tan of A plus B. And you don't need to learn them off by heart, right? But there they are. Sine of A plus B is sine A cos B plus cos A sine B. Cos of A plus B is the two causes, and then the opposite sign minus and the two sines, right? The tan one we'll come to in a minute. So what do I mean by a double angle? Well, what if A was equal to B? So if A was equal to B, I'd have sine of A plus A, which is 2A. And we call that a double angle, right? So what I'm going to do, I'm going to rewrite out this sine A plus B. I'm going to rewrite that out, but swap every B for another A. So I've got sine of A plus A equals sine A cos A plus cos A sine A. And of course, 2 times 3 is 6, and 3 times 2 is 6. Doesn't matter which way around they are. Those two things there are the same. Right? They're both the same. So I have effectively 2 sine A cos A. So that is your first double angle formula, right? Sine of 2A is 2 times sine A times cos A. And you don't ever need to derive them. I'm going to show you, you're just going to have to learn these. There'll be 5 of them you need to learn off by heart. You don't need to know how to derive them, but it's handy to know where they come from, because one year on a past paper question, they tried to catch us out, and we'll speak about that later. So that's the sine one, okay? Sine 2A is 2 sine A cos A. So let's have a look at the cos one. So let's go back to this cos identity given to you in the formula booklet. Cos of A plus B is that. So what if I had cos of A plus A to make cos of 2A a double angle? So if I replace these B's with the letter A, look down here now. I've got cos of 2A is cos A, which is cos squared A, and sine A, which is sine squared A. And if it's a plus here, it's the opposite sign here. If that was a minus there, that would be a plus there. Okay, so the cos of 2A is cos squared A minus sine squared A. And that is on its own an identity that you need to learn off by heart the night before you go into the exam. I'm sure you remember, though, from year 12, that cos squared plus sine squared is 1. So if we fiddle about with this a bit and do some basic substitution, if I replace, for example, this sine squared A here for what would be 1 minus cos squared, if it comes over, if I replace that, I would end up with cos of 2A is 2 cos squared A minus 1. And if I rearrange this differently and I swapped this cos squared A here, brought that over and had 1 minus sine squared A and replaced it up here, I would effectively have cos of 2A is 1 minus 2 sine squared A. Now these here are really important. They're the ones we're going to use the most in this type of question, right? And once you see it, it's not as daunting as it may be at the moment. Any questions so far? So at the moment, we've got sine of 2A is 2 sine A cos A. You just need to know it. And cos of 2A are those two there. And you just need to know them. But if you did happen to forget them, you could derive them yourself using these identities that are in the formula booklet. The tan one is a bit more stinky. Here's the identity for tan of A plus B that's given to you in the booklet. Okay, so if I swap that letter B for another A to make my double angle 2A and swap those B's for A's there, I end up getting 2 tan A on the top and 1 minus tan squared A on the bottom. Right, now if we was in class now, I'd move on straight away and say, right, you know where they come from, but effectively, you just need to have these 5, is it 5 or 6? 2, 4, 5. 5 identities in your head on the day of the exam. And every year I've done this, I've said, when you get into the exam, one of the first things you should do on the front of your paper is write down your 5 double angle identities, right? And then when you need to access them later in the paper, you haven't got to be dredging through your memory, they're there, right? So you learn them off by heart because you will apply them probably twice in the exam, and we'll talk about that in a moment. Everybody cool so far? Can someone just fib and put a yes in the chat so I realize I'm not talking to myself? Pretty please? Thank you very much. Right, okay, so you're still there. So let's have a look how we apply these. Right. Usually on the old C4 paper, it would be question 3, and they would just ask you to solve an equation with a double angle. Okay, and what you would do, you would have to substitute the double angle for one of these identities, depending on if it was sine, cos, or tan. And then you'd either have to look for some form of factorizing, or 9 times out of 10, you create a quadratic equation and then go from there. If you're lucky, it factorizes. If you're not, you have to use the formula. And then you'll do your bow ties or your graphs, whichever way you're most comfortable, to find all the other solutions as well. So let's have a look at one, or let's have a look at 2 actually, and then you're going to try 2 yourself. So apologies for my amazing handwriting. Right, this is a very easy one. All of these are past paper questions. I haven't made any up for the sake of it. These are the types of things you would get on the exam, right? So example number 1, sine 2 theta equals cos theta. And they want all the solutions of that between 0 and 360. They don't generally go any different to 0 and 360, right? Now, this is an easy one because we only have one option for the double angle in sine. The sine 2 theta substitution is 2 sine theta cos theta. All right, so have a look how I've solved this here. So I've substituted sine 2 theta for that there, 2 sine theta cos theta. I've brought this cos theta over, and obviously it's become a minus, and I've put all of that equal to 0. All right, so my nerd skills kick in here now. I see I can factorize that. Cos is in both of those parts of the equation. So I'm going to bring cos theta out, and then in the brackets, I'll have 2 sine theta here minus 1 here. All right, and I'm sure you can all handle that factorizing there. Cos comes out, and in the bracket then is 2 sine theta minus 1. So one of these 2 parts must equal 0. So either cos theta equals 0 or 2 sine theta minus 1 equals 0. If cos theta equals 0, you should know this just from your basic trig graphs. Theta must be 90 or 270. And if 2 sine theta minus 1 equals 0, then that minus 1 would go over, and you'd have 2 sine theta equals 1. The 2 would go over as a divide, and you would have sine theta equals a half. And you probably should know that in your head, but if you didn't, press some buttons on your calculator, and theta comes out as 30, and then you use your graphs or your cast diagrams to get the other solution of 150. So there's the 4 answers there that satisfy that equation up there. Now, if you had loads of spare time, and trust me, you won't, you can check if this is self-marking. You can check if you've done this right. You can chuck in theta is 90 and type in sine of 180 and see if it equals cos of 90. And it does, okay? You can always check your answers on these questions. But believe me, you're going to be pushed for time. Right, everybody cool? I'll take silence as yes. Let's look at the next one. If anyone wants to say anything or type it in the chat, do so. Okay. All right, let's look at example 2. Now, example 2, 2 plus 3 cos 2 theta equals cos theta, again, between 0 and 360. Now, my double angle here is cos 2 theta. And if you remember, let me scroll back up. If you remember, we have 3 options for cos 2 theta. We have cos squared minus sine squared, which very rarely gets used because it's complicated. We can replace it with a sine squared, or we can replace it with a cos squared. If you go back to the question, if you be a bit savvy, look at this other term here. If I replaced it with a sine squared, I'd have a sine squared and a cos, and that's just going down a dark path of pain and suffering. If I replace it with a cos squared, I've got a cos squared and a cos and a constant value, and I could create a quadratic. Okay, so that's the way I'm going to go. I'm going to replace this cos 2 theta with this double angle identity, and then try and figure out if I can solve a quadratic in it. Okay, so let's go through it step by step. So replace this, I get 3 brackets, 2 cos squared theta minus 1. Multiply that out. I now have 2 plus, this multiplied is 6 cos squared theta, this multiplied is minus 3. I haven't skipped a step there. Tidy it all up now and put it into ax squared plus bx plus c form, i.e. a basic quadratic equation form. So get the 6 cos squared at the start. Bring that cos theta over, it becomes a minus. 2 minus 3 is minus 1, and put that equal to 0. Now you can see I've written over here, use the formula, because I think your newfangled bits of plastic could probably solve that for you straight away, because they have the quadratic formula on them, I think. By all means, go ahead and use the formula. If you're old like me, you might prefer more traditional methods like factorizing, which is what I've done here. So I've factorized this. If you just think of it as 6x squared minus x minus 1, you'd be able to do it no problem. But don't let the words cos or sine freak you out. So this factorizes to 3 cos theta plus 1 and 2 cos theta minus 1. Let's just double check. Multiply those, I get my 6 cos squared theta. Multiply those, I get plus 2 cos. Multiply those, I get minus 3 cos, which gives me the minus 1 cos. Multiply those, I get my minus 1. So for this bracket, 3 cos theta plus 1 equals 0. So cos theta will equal minus a third. The plus 1 will go over as a minus 1 and then divide through by 3. Chuck that in the calculator and use your graphs or cast diagrams, and there's the 2 solutions for that bracket. The second bracket, 2 cos theta minus 1 equals 0. Take the minus 1 over, it becomes a plus 1. Take the times 2 over, it becomes a divide. Cos theta is a half. Hit some buttons, and you get your 2 values of 60 and 30. Now, again, if you were so inclined, you could substitute one or all of those 4 values into the original equation to check it worked. Okay? You don't have to, obviously, but if you're not confident and you're wondering if I've made a mistake, you might want to check that. Right, any questions? Ding. Okay, so I'm hoping you've got, if I haven't printed this off, just got a blank sheet of paper and a pen in front of you. No cheating if you have printed it off and looking at the answers. I'd like you to try this one, please, right? So my double angle is cos. So my options are cos squared and sine squared, avoid like the plague. Sine squared isn't going to help much because I'll have a sine squared and a cos, which is not good. So I'm going to substitute this for the cos squared one. Rearrange it all, create a quadratic, and solve it. And if you've got your calculators with you, I'm sure your calculator will do that, right? So please copy that question down, copy this down, and then I'll scroll it back up so you can see the identities. Anybody want to say anything? Just like Happy New Year? Wow. Right. So there's the identities. Obviously, I'm going to suggest you use this one here. So replace that cos 2 theta at 2 cos squared theta minus 1. Right, I'll read that out again now. I'll go back to the question and read it out again. So replace this for 2 cos squared theta minus 1. Put it in brackets, multiply it out by the 2, tidy it all up, etc. And see what happens. And if, when you think you have anything that looks like some sort of answer, can you please just type in the chat, done it, so I have some idea of how long to sit here in agonizing silence. Anybody getting anywhere? Awesome, thank you, Natasha. How do you find the angles at the end? Right, so I'm hopeful that if you have factorized it, your left bracket will say 4 cos theta plus 3. Do you have that, Hannah? 4 cos theta plus 3. Brill. So that plus 3, you put that equal to 0. That plus 3 would go over as a minus 3. The 4 would come over as a divide. So you would press inverse cos, shift cos, whatever your button is, and then in brackets minus 3 over 4. That'll give you the one solution. And then you either use your CAST diagrams or your graphs. You know I like to use graphs to work out the other solution. Right, so I'll give you another 60 seconds of agonizing pain and silence, and then I'll go through this one. And you might be thinking, my other bracket or my other part looks a bit wonky, but it's not. Don't forget, sine and cos can only be between 1 and minus 1. So if you've done it correct, and I'll show you obviously in about 30 seconds, the other bracket doesn't have any solutions. And your calculator wouldn't pick that up, it just would only give you one answer. Right, let's have a quick look at the answers to this one then. So, I replaced the double angle in cos with 2 cos squared theta minus 1 because I could see that down the line I'm going to rearrange all of that and create a quadratic. So they were, I'm not cutting any corners, just write that out again as 2 cos squared theta minus 1, then multiply it by the 2. So there's my 4 cos squared theta. Bring over the 9 cos theta and it becomes a minus. Bring over the 7 and it becomes a minus. So I got minus 2, minus 7, which is minus 9. So there is my quadratic in terms of cos theta. You all seem to have gone for your calculator, which is absolutely fine, but make sure you know how to get all the solutions from your calculator. This factorizes. it factorizes into 4 cos theta plus 3, and then cos theta minus 3. Now this is the bit I was just alluding to. If cos theta minus 3 equals 0, take the minus 3 over, it becomes a plus, and you have cos theta equals 3. And there are no solutions for that. Right? Cos theta can only be between 1 and minus 1, so you just write down to the examiner no solutions. My other bracket was 4 cos theta plus 3 equals 0. Plus 3 goes over as a minus, 4 goes over as a divide. Hit shift cos on minus 3 over 4, and your calculator will give you that solution, 138.6. And for cos, then you do 360 minus that to get the other solution, which is 221.4. Right, that'd be 4 marks, that would. Anybody manage to get those 2 answers out? You can just lie here and say, yes, you know, I'm not going to know, am I? Well done, Hannah. Fibbing, probably. Right, very good. Right, let's have a look at another one then. So this time we've got 3 cos 2 theta, my best handwriting, equals 1 minus sine theta. And again, I want them from 0 to 360. Obviously, there's no point swapping that for the cos squared. I need to swap this one for the sine squared, and I'm going to create a quadratic in sine. So the sine squared one that you will learn off by heart is cos 2 theta is 1 minus 2 sine squared theta. Right, it's 1 minus 2 sine squared theta. If I scroll back down to the question, so swap this in brackets for 1 minus 2 sine squared theta. Multiply out the bracket, tidy it all up, so you get a quadratic. Make sure you got all your signs correct, and then either hit the buttons on your calculator. This one also factorizes as well, okay? And you will get 4 solutions for this question. So I'll give you 2 to 3 minutes. See if you can get all 4 solutions, please. Any questions, check it in the chat, or even, God forbid, turn your microphone on and say something. As well, have a quick game of Among Us. Anybody getting anywhere? Well done. Thank you, Hannah. Did you get 4 solutions? Yes. Right, I like it. Accents in the chat. Yes. And I'm hoping 2 of those solutions were whole numbers. I'll give you another 30 seconds. Oops. Okay, let's go through it then, have a look, see what I got. So, again, the key is picking the right substitution when it's a cos double angle. Because there was a sine there, I know to go with the sine squared and create a quadratic in sine. Got to be careful with your polarity here, your pluses and minuses, right? So I've got 3 brackets, 1 minus 2 sine squared theta equals 1 minus sine theta. And what I've done, I've been a bit cheeky here and skipped a few steps. So I've multiplied this out and took it all over there in one go. So that was a bit daft of me, right? So I've got minus 6 sine squared theta by multiplying those, and I've took that straight over. Then I've got the minus sine theta, which is there. 3 times 1 is 3. Take that over, it's minus 3. 1 minus 3 is where I get that minus 2 from. So there is my quadratic in sine theta. I need to press buttons now on your posh calculators or factorize it. It factorizes as this. If this bracket equals 0, then sine theta would equal 2 over 3. The minus 2 would go over, become a plus 2. The 3 would go over as a divide. If I hit shift sign of 2/3, my calculator will tell me it's 41.8. Get my other solution between 0 and 360, I do 180 minus that. Get 138.2. This one here, the plus 1 goes over as a minus 1. The 2 goes over as a divide. I have sine theta equal to minus a half. And if you know your graphs, picture the sine graph. The two values of theta that are at minus a half are 210 and 330. Okay? Anybody want to fib and say they had them right? I'll just take that as a silent yes. I'm sure you're all nodding profusely. Right, let's look at a couple more then. Two more to look at. Straight off the exam paper. 6 marks. I don't think they're worth 6 anymore. I'm not going to fib. I think they're worth 4. I don't know why they dropped the allocation, but look at this straight away. The double angles in cos. My other trig term is sine. So this is going to be, swap it for the sine squared one, right? So again, I'll tell you that cos 2 theta is 1 minus 2 sine squared theta. So swap this for 1 minus 2 sine squared theta. And then see the question through, very similar to the one we just did. And again, there are 4 solutions. Okay. So have a crack at that one. I'll give you 2 minutes. Anybody making any progress on this one? 4 solutions, 2 of them are whole numbers. Thank you, Hannah. Can someone else let me know when they've done it, and then I'll go through it. Nice one, Jacob. Can I ask, right, I'll ask this to Jacob. When you get to the quadratic, mate, are you then using your calculator to get all 4 solutions? Does it give you all 4 solutions, your calculator, or does it just give you 1? Okay. Well, that's a bit handy then, isn't it? That's why they've dropped the marks down to 4, look. Right. Well, that's practically cheating. I'm in the mood now. So let's have a look at it. So again, you'll start to become quite savvy in picking which substitution to use. So that's going to be 1 minus 2 sine squared theta 1. I've written it. And you'll need to make that clear to the examiner. That's what you're doing. Multiply out the bracket, tidy it all up, and create a quadratic. I do tend to skip a step there, so I do apologize. So there was my quadratic. 8 sine squared theta minus 2 sine theta minus 3 equals 0. This one does factorize. It factorizes to 4 sine theta minus 3 in the one bracket and 2 sine theta plus 1 in the other bracket. Take that minus 3 over, it becomes plus 3 divided through by the 4. Hit shift sign of 3/4 and your calculator will tell you 48.59. Then use your graphs or cast diagrams to get the other value of 131.41. And then the second bracket was the same as the last question we did. Sine theta came out as minus a half, and you'll start to learn these off by heart. That the solutions for minus a half in sine are 210 and 330. Okay, brill. Right, one last one, and then I'm going to give you a little bit of homework. One last one to look at. This one looks a little bit juicier again. So I've got 8 cos 2 theta plus 6 equals cos squared theta plus cos theta. Okay, you've got 3 options to substitute your cos double angle. Cos squared plus sine squared, that's no good. There's no sines anywhere near it. The sine squared one isn't going to work either. So this time you're going to substitute it for 2 cos squared theta minus 1. All right, so I'll tell you in case you didn't write it down. That now will be substituted for 2 cos squared theta minus 1. Multiply it out. Tidy up the cos squareds, first of all. Then put it into a quadratic formula format. Ax squared plus bx plus c equals 0. And then I imagine most of you are using your calculator. But this one also factorizes. So if you fancy giving yourself a challenge, do it that way. We'll see what happens. I'll give you 3 to 4 minutes. If you've done it and you'd like to let me know in the chat so I have some idea of how long it's taken, I would be very grateful. All right, so off you go on that one. Oh, blinking over. Thank you, Hannah. I've got no whole number solutions for this one. This one, they all came out a bit stinky. So if your answer is 30, I think you got it wrong. I'm sure you haven't. Say hello to the most talkative year 13 class you've ever met in your life, Mr. Deal.
No, I'm missing.
There's 11 of them there. They're talking in the chat, but they will not speak to me. Can you say hello to Mr. Deal? Anybody? Otherwise, you don't think you're there.
Give all attention, sir.
I will. after school.
Hello, Catherine, you can type. Well done. Anyone speak?
They won't speak. They don't speak in class.
Right, try your 50.
Ta-ra, Mr. Deal. Right then, anybody got 4 solutions for that? What's that pinging noise? I don't know what that noise was. Anybody got 4 solutions? Are people still working on this question, or shall I show the answers? Okay. Thanks, Natasha. Right, I'm going to go through the answers then, right? Right, this one. So again, at the spot that we were going to substitute the double angle for the 2 cos squared minus 1. So chuck it in the bracket there, multiply it out and tidy it up. And again, stupidly, I skipped a step, so I do apologize. So I've got 16 cos squared theta, but I'm going to bring this one over, which is where I get the 15 cos squared theta from. I'm going to bring this cos theta over, and it'll become a minus. And then I've got minus 8 from multiplying out that bracket, plus the 6, which gives me the minus 2. So there is my quadratic equation in cos that you can chuck into your calculator if you want, right? It did factorize into 5 cos theta minus 2 and 3 cos theta plus 1. So the first bracket, the minus 2 goes over, becomes 2 divided through by the 5. Cos theta is 2/5. The calculator will give you 66.42. Your graphs then tell you to subtract that from 360 to get the other value of 293.58. The other bracket, 3 cos theta plus 1 is 0. Take the plus 1 over, becomes a minus, divide through by 3. You get cos theta is a third. The calculator will tell you it's 109.47. Subtract that from 360 to get the other solution of 250.53. Right? Anybody get those 4 answers there correct? Notice I went to 2 dp. I don't know why. I don't know if it says. No, it doesn't say. I went to 2. Anybody get them? Someone just fib and say yeah, so I can move on. Yeah, nice one. Awesome. Well done. Thank you. Right. So that's pretty much it. Okay. But I'm sure you were thinking, well, hang on, sir, you haven't done a tan one. And there's a reason, okay? What I'd like you to do now for your homework, I'd like you to go to YouTube and type in Bedrest Maths. Go to the Key Stage 5 playlist, and I'd like you to watch these 4 videos here. So he sounds like a very handsome young man doing these videos. From 2014, 15, 16, and 17. They're all question 3, apart from 16, which is question 4. And they're all tan questions, right? And I'd like you to just, when the video starts, just click pause and look at the question before I go through the answers. Have a go at them, and then just watch me go through the solutions. Some of them are rather juicy. One in particular, we actually filed complaints about because it was a bit too difficult, we thought, at the time. But I'd like you to see what the tan ones look like, right? They're a bit more algebraic, and I don't want to freak you out now on the live lesson. So I'd like you to please do that. What's also important is, on the new spec, you're not always guaranteed now to get a question like the ones we've just covered. It does come up, and sometimes it doesn't come up. But what definitely will happen is it will be embedded somewhere else. Now, if you can remember our integration by parts and integration by substitution questions, at our level of mathematics, we can't integrate a cos squared or sine squared. And sometimes they ask you to do that. So what we'll look at next time is that type of question where you then substitute a sine squared or a cos squared for a double angle, and then you can integrate that. Okay, so if I integrated sine 2 theta, the 2 would come out as a half, and the sine would turn into minus cos, right? So I'll just repeat that because that was a bit of a mouthful. You will be asked to integrate a sine squared or a cos squared somewhere on the paper. And to do that at this level, we use the double angle substitution, fiddle about with it and tidy it up, and then integrate the sine 2 theta or the cos 2 theta. And we'll look at that either next time or another time, right? My main goal for today was get you to solve these type of questions here. And I feel we've had some success on that. But I really need you to go look at the TAN questions as well on the Bedwas Maths YouTube channel in the Key Stage 5 playlist, right? So either quickly take a photo of that, or obviously I've uploaded all of this onto Google Classroom. Feel free to leave any comments, even if you just say, yeah, I watched them, sir, they were solid, or I watched them, I had a go, and I think I would have had some success, right? And that's it. That's it for me today. Would anybody like to say anything, either verbally or via the chat? You're very welcome, Bethan. I don't know how you're getting on with these online lessons. It's a bit different, but it's the best we can do at the moment. You're welcome, Griff. You're welcome, Hannah. You're very welcome. Oh, Brill. Well, I'm glad to hear that. Bounsy's on Friday. Okay, because I'm on a course that Mr. D was making me go on. So it's Bounsy's turn Friday, and then it'll be back to me probably then next Tuesday. We're going to work very fluidly with the science department. Because it's only really maths and science I think you're getting the live lessons for at the moment. So just keep an eye on the stream, because you might only get like a couple of hours notice. Oh, your lesson's coming up. You know what Mrs. O'Mal is like, etc., etc. So please have a look at those videos. Thank you for coming on to the lesson. Please take care, and I will speak to you very soon. All right, so this is Mr. T out. Bye-bye. Bye, Catherine.